Okay, so the setup to this question is very similar to the previous part. This is just a more complicated variation of it. So, we've got, we know that we've got a tension through the cable there, which is at some angle theta, where we know that sine theta equals 4/5. We've got the mass of the crane itself, which is 500 G, and that's at a distance of 4 meters. It's the midpoint. We know that our 1200 G is no longer at the end, it's at some length L. Okay, so looking at my forces, I've got my force X and my force Y, and we know that the overall magnitude, so x squared plus the square root of x squared plus y squared, must be less than 20 kilonewtons, and we're trying to find out what values the length can take. So let's just put our lengths in on here. So I've got 3 meters down to this point here. I've got another meter, and then I've also got this distance here is some length L. Okay, so we're going to start by taking moments about the pivot. So we're going to take clockwise moments about the pivot, and we know therefore that 4 times 500 G plus L times 1200 G equals 12 over 5 T. And I'm just using that 12 over 5 T, which is exactly what we had in the last question. That's unchanged. So I've got 2000 G plus 1200 LG equals 12 over 5 T. I'm also going to resolve vertically. So I'm going to now say that here, for the vertical component, I've got T sine theta equals my downward forces. Here I've got 1700 G plus Y. Now, I know that sine theta, looking at my diagram, this is theta, so sine theta is 4/5, which I've got over here. So I've got 4/5 of T equals 1700 G plus Y, and resolving horizontally, I've got X equals T cos theta, and cos theta is 3/5, so X equals 3/5 of T. 1, 2, 3 equations to use. Our challenge is how we can use those and the limit on x squared plus y squared to help us identify L. Okay, so now that we've got our 3 equations, what we're going to try and do is to express both x and y in terms of L and G. So we want to get rid of T. So we're going to use the first equation to get rid of T. So this is my first equation here. And I'm going to make T the subject, which is going to give me 5 times 2000 is going to give me 10,000 G over 12. 5 times 1200 is 6000, divided by 12 is 500, plus 500 LG equals T. Okay, so I've now got an expression for T. I now know that Y equals 4/5 of T minus 1700 G. So I can do 4/5 of this, so it's 4/5 of 10,000 G over 12 plus 500 LG minus 1700 G. That's going to give me 2000 over 3 G plus 400 LG minus 1700 G, which gives me 400 LG. That's minus 5100, so minus 3100 over 3 G. And that's my expression for Y in terms of L. X in terms of L is somewhat easier, you'll be pleased to know. So X equals 3/5 of 10,000 G on 12 plus 500 LG. And that should just give me 500 G plus 300 LG. Now, we know that the magnitude of the force has got to be less than 20 kilonewtons. So I know I'm going to start up here because this starts to get complicated. The square root of x squared plus y squared, we're going to keep it as an equality just to make it easier for the moment, equals 20 kilonewtons, which is 20,000 newtons. So squaring both sides gives me x squared plus y squared equals 400 million. So substituting in, we've got here, what I'm going to take 100G out of the bracket. So I've got 100G, lots of 5 plus 3L. And that's all squared. Plus, and I can do the same here, I can take out 100G. 100G, lots of 4L minus 31 over 3. Squared equals 400 million. That's going to make my life a lot easier, because then what I can do is say, well, 5 plus 3L squared plus 4L minus 31 over 3 squared is going to equal 400 million divided by 100G squared. Just be careful when you're doing this that it's not just 100G squared, you're actually squaring both the 100 and the G. Multiplying out the brackets here gives you 25 plus 2 lots of 15L, so plus 30L plus 9L squared plus 16L squared. 4 times 31 is going to be 124 over 3. You get that twice, so minus 248 over 3L plus 961 over 9 equals, we're going to have to work out what 400 million works out as 416.5. Again, I'd make sure that you save that value onto your calculator. I'm just going to store it in A. We're on the home run now. I've got 9L squared plus 16L squared, which gives me my 25L squared. I've got plus 30L minus 248 over 3L, which is 90 minus 248 minus 158 over 3L. And bringing all the numbers over to the left-hand side gives me into your equation solver on your calculator rather than trying to work it all out yourself, and it gives you a value of L of 5.64 meters, or a negative value of minus 3.54 meters. Obviously it can't be a negative value, so it's only safe if the force here can be as much as 20 kilonewtons. It's only safe for that weight to go out to 5.64 meters. That's nothing there is beyond the scope of the A-level syllabus, but it's more difficult than anything I've seen, so well done if you managed to get that far.